Lesson 6, Characteristics of Absolute Value Graphs. Again, your I can statements that I can graph an absolute value function and I can translate the graph of a function using our parent. Thinking about yesterday's assignment we worked on, what is a parent function of the absolute value? We should be thinking it is always our y equals absolute value of x. If I was asking what does the graph look like, you should easily be telling me it is that V-shaped graph. When we think of it being V-shaped, we want to think about what was the slope of each one of these rays, and keeping in mind that the slope of this line, the slope of that ray, is going to be a positive one, and the slope of this ray, when it's our parent function, is a negative one. So it's always just going up one and over one, up one and over one to find those points. Same thing here, up one and back one, up one and back one to find those points. So we're going to use some graphing calculators tomorrow in class. If not graphing calculators, hopefully using internet and using graphing calculators online. And the key thing we want to look at is what is going to be the slope now of this next line. Now, if we are looking at this one, as we put this in our graphing calculator, or in this case, as we look at this, and I'm going to show you a few things in just a minute here. Now, when we look at our graphing calculators, we will be putting our equation in to our graphing calculator. And you'll see me put it in a minute. But the key thing is I want you to just think about, what is this point telling us? The 1 and the 2. Remember, that's helping us with our vertex. So when we look at the vertex of this is always going to be our x-coordinate and our y-coordinate. So what do we add to 1 to get 0? That is our vertex. And as we look at that vertex point, that is going to be -1. Remember, it's the opposite of that. What is the -2 telling us? To go down to -2. So if we were looking at this graph and we wanted to put a coordinate grid over here, the first thing that we know if we were going to start graphing this from today's and yesterday's assignment is that the first thing we know is that this point is located at -1, -2. Now, because of what's out in front of the graph, the slope hasn't changed. So since our slope hasn't changed, we are still going up a +1 at this point, and this is a -1 slope on this side of our graph. So if we were looking at that, we could now graph and check these points, okay? So when we think about this, the slope of each branch, the one slope, is a +1, and that would be on the right side. That's a positive slope. And the slope on the other side will be a -1. That's our left side of our ray, if we look at that. So our +1 slope and our -1 slope. We now know the vertex. As you look at this graph, can you even tell me what are the x-intercepts? Remember, x-intercept is simply where does it cross the x-axis? Well, we have 2 of them. One of them is going to be at, if we go over 1 to the right, 0. The other one is going to be at -1, -2, -3, 0. It asks you what the domain of the function is, and I want you to think about that. Domain is what x values could you put in? Well, we should be able to put in all our x values to the left and right. So we're going to say that our domain is going to be all real numbers, keeping in mind that this is our x, okay, all real numbers. But when it asks us what is our range is the y values. Well, the y's are going to keep going up, but what is their starting point? So that's what we want to be taking a look at. We're going to say that y is where y is greater or equal, because it actually could be -2. Y is greater or equal to -2 for all real numbers. It says, how do you notice the connection between the vertex and the numbers in the equation? So we're going to look at that in just a minute, but I'm going to pull up the graphing calculator because I want you to see on the graphing calculator how we'd enter this. We put it in as our y equals, and so again you always want to make sure that everything's cleared out. As you do that, we'd put in our absolute value. Now in the absolute value on the graphing calculator, you have to go under the math function, and then I believe it is, nope, that is not where it's at. Absolute value, first one under the number. So it doesn't give you actually those lines, it just says ABS. So I'm going to hit enter. And what am I trying to find the absolute value of? I'm trying to find the absolute value of x plus 1. And then I have to put the back parenthesis because that tells it what it's finding the absolute value of. And then it'll say minus 2. Now, again, when I go to graph this, I want to make sure that I'm on my standard window. So I'm going to go to zoom, and I'm going to choose 6, which is standard. And we should see that same graph. And again, if you want, nice thing about the graphing calculators, you can also look at the table by hitting second table. And you can see all of our values. Now, we probably want to get a little closer to 0, not at negative 13. And we can see our vertex was at negative 2. If we were looking at that at negative 1, negative 2, and notice around that point how it just is going to be symmetric as we look at that. Okay. Now, it says, well, what do we notice about the connection of the vertex and the numbers in the equation? So when we look at our vertex, here's the key thing. You are looking at x plus this number, and then you might have plus another number outside your absolute value. Remember, these are your absolute value signs. And the same would be if we think of this as being plus or minus a number. So sometimes we might think of it as x minus that number inside the absolute value, and then if this is minus another number. So if I'm looking at that, what is the connection? Well, when it's a plus in our vertex, this number will be the opposite. If it's a plus, opposite the x coordinate. So in our case, it was a positive 1. Notice that when we had absolute value of x plus 1 minus 2, that this was a negative 1. You would also notice if this would have been a plus number, so in our case, if it would have been a plus, then this would be the exact same number. Whatever that plus is, that's going to be the same number. That's our y coordinate. So again, if you have it in this form, what are we looking at? Well, if it's a minus, this is our x coordinate, and in this case, it would be that exact number. So because it's a minus, remember if you'd have absolute value of x minus 2, what do you add to negative 2 to get 0? You would put in a 2. So it's going to be the same number. In this case, it would have been a 2. This is our y coordinate, and it's going to be opposite because of this being a negative number. It's going to be that negative number 2, and it is your y coordinate. And I think most of you are getting that down from your homework that you were working on in class on Friday. So if we graph each one of these, we want to try and decide, does it open up or down? And as we look at those, so one of the things that we will look at in class when we practice more of these is we're going to be looking at the graphing calculator. Real quick, if we are looking at them, what's the one determining factor for going up and down? That's in front of here, the positive or negative. So if we are looking at which ones go up, our up graphs in this case should be y equals the absolute value of x minus 3 minus 4, and the other one should be y equals the 2 times absolute value of x plus 3 minus 4. If we're looking at the ones that go down, our two down ones would be the ones with our negative in front. So both the ones where you have y equals a negative absolute value of x minus 3 minus 4, and y equals the negative 2 times absolute value of x minus 3 minus 4. How does the sign of the coefficient in front of the bars affect the direction it opens up and down? Well, and we're going to put it in our graphing calculator, and you're going to see them. Positive goes up, negative goes down. So just to kind of take a look again at your equations, I'm going to leave We're going to clear this one out, and I'm going to put in some of these equations so you can see them, and then we will take a look at that. At this point on my calculator, I have put in all of them but the last one, and I just want to walk you through putting that last one in, and then we're going to look at the graphs of each of these. And when the graphs come up, they're going to come up in order. So that last graph that we were putting in had a +2, so we put +2. If it was negative, this is the negative key you use, not the minus. So negative. Then we hit math, again, to get absolute value. Arrow over to this where it says num, then you have ABS, absolute value. I hit enter. I am now going to put the x plus 3, so x plus 3, back parenthesis, and then it was -4. Now, again, as you watch these graphs, you're going to see each one graph in order. First our parent function, then the negative absolute value, the positive absolute value of x minus 3, the -2 times it, and then this last one. So they'll come up in that order. Parent function. There's our first negative one. They share the same vertex. Here, again, sharing that same vertex. And what you're noticing is that these two are a little steeper, okay? Now, what are the slopes of the left and right branch of each one? Well, when we look at that, every single one of these, or for the first, I would say 2, we are looking at, for this one and this one, our first 2, the graphs were exact, slopes were the same. So what is the slope of the left branch? The left was a -1. When we look at the right branch of each graph, the slope was a +1. But what happened when we took it times 2 and -2? That's when we had the 2 and -2. So in this equation, our slope was now -2. And here, in both of these, this one and this one, our slopes changed so that m was equal to a +2, and here our slope was a -2. It says, what does the slope to the left branch relate to the right branch? They should be opposites if we are looking at that. They're exact opposites. Can't spell today as I'm writing this. What does the coefficient, how does that affect the slope? Remember, what did we say in that very first video on absolute value? If it is a number greater than 0, so if we think of m, our slope, being greater than 1, or m is less than -1, meaning both positive and negative, bigger numbers, it is going to be a steeper graph. Whereas if the slope is a number between 1 and -1, meaning that we really have a fraction or a decimal, right, positive or negative, it's going to be a wider graph. When you come to class, we hopefully will have the technology working to have this done. So it says now we want you to make a prediction. Without graphing it, don't try to pull something up and graph it. Just look at this and try and make a prediction. Where do we think the vertex would be? What direction? What slope should the branch be? And what should the domain and range should be? We're going to look at this tomorrow when you come into class and see how you did. Hopefully this made sense.